So we're still talking about chemical formulas, but this time we're going to write chemical formulas. This is section 2.3. Okay, so remember that in section 2.2 we did have a reference sheet in our fingertips, and it had a list of the common polyatomic ions as well as the chemical formulas. It also had a periodic table on it so that you could determine the charges of common elements when they formed ions. Remember, we're only going to be using the group A elements in order to do this. And then the last thing is that you must memorize the 10 prefixes for covalent compounds. Those are not on the reference sheet. So remember, a binary ionic compound contains two elements, a metal and a nonmetal, and it's formed between positive and negative ions. And we're going to focus in on those ions at this point. So how do we write a formula for a binary ionic compound? Well, the first thing you have to do is recognize that this compound is going to end in "ide," except for hydroxide and cyanide, and it will not contain covalent prefixes. To write the formula, all that you're going to do is take the symbol and the charge of the first element, which is the cation, the symbol and the charge of the second element, which is the anion, and you're going to look at the charges. We're going to add more cations or anions, depending on the situation, in order to get a neutral compound. We don't want to have any charge at all in the compound. And we'll use subscripts to show how many of each type of ion is present in order to get neutrality. So let's do example 1, sodium chloride. I know this is a binary ionic compound because it ends in "ide," and it contains a metal and a nonmetal. I'm going to go to the periodic table, find the symbol for sodium, which is Na. It's in group 1, so it's going to have a +1 charge. I'm going to find chlorine, which is in group 7A. Its symbol is Cl, and it has a -1. And I'm going to look at the charges. Notice that the +1 and the -1 actually equal 0. So what that means is this chemical formula is going to be in a 1-to-1 ratio. But we don't write the ones, and so we're just going to write NaCl. Let's take a look at a second example. Once again, it's a binary ionic compound. I know this because it's ending in "ide," and it's made up of a metal and a nonmetal. So I'm going to go to my periodic table. I'm going to find calcium. It's in group 2A, so its symbol is Ca, and it has a charge of +2. I'm going to go to bromine on the periodic table, which is Br. It's in group 7A as well, which is a -1. And this time I'm going to look at the charges and realize that the +2 and the -1 will not equal 0. And so now I'm going to have to decide how many of each ion I need in order to get neutrality. Well, hopefully you can see that I can add another bromine here, and that will give me a +2 and a -2 total negative charge, which will then add up to 0. So the correct chemical formula here is Ca1Br2. Remember, we don't write the 1, so it's really just Ca-Br2. So there is a shortcut to writing chemical formulas. It's called the crisscross method, and you do what you did before. You write the symbol and the charge of the first and the second element, but you cross only the charge numbers down diagonally to make subscripts if they are not equal to each other. As you can see with the example we just did a second ago, we will take the 1 and move it down here, and the 2 and move it down here. Those give you the subscripts of Ca1Br2, and then once again we know that the 1 doesn't need to be written, and we end up getting Ca-Br2. Of course, understand that basically this is giving you that ratio that you were guessing in the last slide, because 1 calcium at +2 is a +2 charge, and 2 bromines at -1 gives you a -2, which then gives you 0. So it's time for you to do your self-check. Go ahead and try to write the formulas for these 4. Go to the next slide to get the answers. Alright, so cesium is Cs in column 1. Chlorine is in column 7 with a -1 charge. The +1 and the -1 can cancel each other out, and so the answer is CsCl. In the next example, potassium is K. It's in group 1, so it has a +1 charge. Oxygen is O, and it's in group 6, so it has a -2 charge. So what we're going to do is do that quick crisscross method, and you'll see that you get K2O. The next one is calcium, which is Ca. It's in group 2A, so it's +2. Sulfur is going to be in group 6A, so it's going to be a -2. The +2 and the -2 will neutralize each other, and so they're going to come together in a 1-to-1 ratio of CaS. And the last one, I've got lithium, which is in group 1, so it's +1. Nitrogen is in group 5A, so it's a -3 charge. Those are not equal to each other, so we're going to go ahead and bring the subscripts of 3 and 1 down, and that gives you us a 3-to-1 ratio for lithium nitride. So now we're going to focus on ternary ionic compounds. Remember, these are compounds that contain at least one polyatomic ion. You'll find that polyatomic ion most likely in the back, sometimes in the front, and sometimes in both places. So how do we identify and write formulas for ternary ionic compounds? These compounds do not end in "ide" except for hydroxide and cyanide. They will usually end in the suffix of "ate" or "ite", and they do not use covalent prefixes. How do we write the formulas? We're going to do the same thing we've done before. Take the symbol and the charge of the cation and the anion, add additional cations and anions to main neutrality, or use the crisscross method, and remember the subscripts will show us the number of ions needed for that neutrality. The only difference is when using subscripts with a polyatomic ion, you have to put the polyatomic ion in a parentheses and the subscript goes on the outside. In example 3, I have a ternary ionic compound. I have a metal and I have a polyatomic ion, and I recognize the polyatomic ion with the suffix "ate". So I'm just going to go ahead and get the charges. Sodium is +1, it's a group 1 metal, and I'm going to go to the reference sheet to look up carbonate, which is capital C, capital O, 3 with a -2 charge. I'm going to look at the charges and notice that they're not going to give me 0 when I add them together. And so I'm going to do my crisscross method, which will give me that quick ratio that will allow those charges to neutralize out. So it's Na2CO3. Notice that this is a +2 and this is a -2 now, which will cancel out and make 0. Example 4 is also a ternary ionic compound. Once again, I see a metal and I see the polyatomic ion. So I'm going to go ahead and get the symbol and the charge. Magnesium's +2. I'm going to go to my reference sheet to come up with the formula for nitrate, which is capital N, capital O, 3 with a -1. And then I'm going to notice that the charges are not going to give me 0. They're not the same magnitude. And so I'm going to do that crisscross. And this time I'm going to put a parentheses around the NO3 because there is a subscript that is needed there. Remember that 1 times +2 is a +2, and 2 of these nitrates at -1 gives me a -2, which then gives me that 0. Now it's time for your self-check. Go ahead and try the formulas for these 4. Check the answers on the next slide. So all these are ternary ionic compounds as seen with the ending "ate", "ite", and of course there's that hydroxide that we're looking out for. And now we're going to come up with the symbol and the charges for each part. So this is Na +1, nitrate is NO3 -1. These are the same magnitude, they cancel out to 0, and so your answer is NaNO3. For calcium chlorate, it's Ca +2. Chlorate is ClO3 -1. Those two magnitudes are not equal, so we're going to go ahead and crisscross. Notice that there is a parentheses around the ClO3 right here, and the 2 is on the outside. The next one is potassium, which is K +1. Sulfite is SO3 -2. So once again, I'm going to do that crisscross, and I'm going to get K2SO3. And the last one, calcium is +2. Hydroxide is OH -1. Those two charge numbers are not the same. We're going to do the crisscross method, and once again I have to put a parentheses around the polyatomic ion if I need more of those ions in order to get neutrality. It does not matter that there is not a subscript on the OH itself. There always has to be a parentheses around the polyatomic ion if there's more than one needed in the compound. So just remember that transition metals are in group B. They're your type 2 metal. They have more than one possibility for cation charge. So how do we identify and write formulas with transition metals? We're going to do the exact same thing that we've just done, but we're looking out for that Roman numeral. The Roman numeral will tell us the charge of that type 2 metal. So this is a binary ionic compound. I know that because it's ending in "ide." I'm going to come up with the symbol and the charge of the metal. Notice the Roman numeral is telling me the charge of iron as +3. And then I'm going to look up oxide, which is oxygen. On the periodic table, it's -2. You can see that those two charges are not going to add up to 0. So we're going to do the crisscross method. That's going to give me the ratio that is needed in order to get neutrality. And I'm going to rewrite my chemical formula as Fe2O3. Example 6 is a ternary ionic compound. I noticed the 8 at the end. And so once again, I'm going to come up with the symbol and the charge of the metal, which is Cu. The Roman numeral tells me it's +2. And then I'm going to look up the symbol and the charge of nitrate on the reference sheet, which is -1. The charges are not going to add up to 0. So I'm going to crisscross those numbers down, and I'm going to put the polyatomic ion in parentheses to separate the 2 from the 3. So here's your self-check in this section. Go ahead and complete and get to the next slide to see your answers. So I noticed the 8, and so I know this is going to be NO3-1 from the reference sheet. Iron is Fe. The Roman numeral is telling me the charge. I will crisscross here, and you see that I get FeNO3-2. Copper is Cu. Its charge is +1, as seen with the Roman numeral. I see it's ending in "ide," and so that means it's just a single nonmetal. I'm going to look up its charge, which is -1. Notice that a +1 to -1 equals 0, and so I'm just going to bring them together in that 1-to-1 ratio. No subscripts are needed. In the next example, I have lead, which is Pb. Remember, that is a pseudo-transition element. That's why there is a Roman numeral of 4 there. And even though this ends in "ide," it's one of the polyatomic ions, so we look that up on the reference sheet. That's OH-1. And you can see a +4 and a -1 don't add up to 0, so I'm going to go ahead and do the crisscross thing. Don't forget the parentheses around the OH. And the last one, I've got tin, which is Sn +2. It's also a pseudo-transition metal. I've got oxygen, O-2, and those two charges will add up to 0. So once again, they're going to come together in that 1-to-1 ratio. Now that we've written chemical formulas for ionic compounds, let's do the same for the binary covalent compound. Remember, that's made of 2 nonmetals that are sharing electrons. So how do we identify and write formulas for covalent compounds? Remember that these compounds are going to have covalent prefixes. And all that you do here is you write the symbol of the first and second element, and you translate the prefix into a subscript. Atoms in this type of bond do not form charges, so you don't need to worry about crisscrossing. So example 7, I see the prefixes of di and tetra, so I know this is a covalent compound. I'm going to write the element symbol of nitrogen, which is N, and oxide is O, oxygen. And then I'm going to translate the prefix as the subscript. And so this is N2O4. Example 8 is also a binary covalent compound. I see the prefix that helps me identify that. I do notice that there is no prefix for silicon. That must mean that there's only one. So as I write the symbol for silicon, I'm going to put a 1. And for oxide, which is oxygen, that's O. And that di is 2. Once again, we don't usually write the 1s. So this is SiO2. Remember, there is no checking of charges, no crisscrossing. You're just translating the prefix into a subscript. Here's your self-check. Write the chemical formulas. Go to the next slide to check your answers. All right, carbon monoxide. Once again, if you don't see a prefix, we know that there's just one, and mono also means one. So you'll notice that there are no subscripts in this first example. It's just CO. For the next one, once again, no prefix, so we know there's just one sulfur, and there are 4 iodines. And the last one, there are 3 chlorines and 5 sulfurs as seen in the answer. So So this is a chemical formula flow chart. Please use it if you are having difficulties at this time writing chemical formulas. It's a good way to get everything straight and to follow the rules, and eventually you won't need it any longer. So this last self-check is mixed practice. It's going to include binary and ternary ionic compounds with type 1 and type 2 metals, as well as covalent compounds. The flowchart might be necessary at this point in time, but go ahead and try to get these chemical formulas written and check your answers on the next slide. In order to come up with the answers, I do need to know which compound is ionic versus covalent. Remember, covalent compounds contain prefixes. Ionic compounds will contain either a metal or the ammonium ion sitting in front. The first, second, and third do not have prefixes, and they all begin with metals, so those will be ionic compounds. The fourth example has the prefix, so that's going to be a covalent or molecular compound. And the last one is also going to be ionic. I see a metal. Now don't get confused with the bi. That is actually part of carbonate, which is a polyatomic ion. So now that I know which is which, I'm going to look at my ionic compounds. I'm going to come up with the name of the metal, or the formula of the metal, and of the, in this case, the polyatomic ion. And I'm going to check the charges. Notice that they're not equal to 0 when they're added together. And so I'm going to get Mg, don't forget once again that parentheses OH2. Copper is Cu. That's a transition type 2 metal. So its charge is +2. You don't have to go anywhere to find it. It's ending in 8, so that's a polyatomic ion. I'm going to look it up on the reference sheet, NO3 - 1. Once again, those charges are not going to be equal to 0 when added together, so I'm going to do the crisscross thing, and that's going to give me that 1:2 ratio. Don't forget to put the polyatomic ion in parentheses. In the third example, I do have a type 2 metal as well. You can see the Roman numeral 3 telling me its charge. It's ending in "ide," which means it's a single nonmetal. I go to the periodic table to get its charge. It's -2. And once again, I will crisscross to get the 2:3 ratio. In the next example, we don't do any crisscrossing. We just translate. Nitrogen is just N, di is 2, and oxide is oxygen, which is O. And in the last example, sodium is Na. Go to the periodic table to get its charge of +1. We notice it ends in 8, so that's a polyatomic ion, which is HCO3. It's also known as hydrogen carbonate, has a -1 charge, and because the +1 and the -1 will add up to 0, they do come together in a 1:1 ratio. Don't forget to put that 3 there because it is part of the bicarbonate ion.